The sun, there are magnetic fields that are like big McDonald's arches, and every once in a while they blow up, and that's what we call solar flare.
Why these arches blow up to create solar flares is the unanswered question. But through his research, Bellin may have found the cause. When an arch forms, it has a tendency to twist.
What we think is happening is that it's getting more twisted, and then when it gets to a certain point where it can't handle it anymore,
Arching,
it breaks,
twisting,
and you get energized particles coming off. It's like an explosion.
Twist, like an explosion, and then it comes.
To bring this type of
motion.
solar flare to life, Bellin and his team use electromagnetism to ignite hydrogen gas inside a large vacuum chamber.
So we introduce the gas, we introduce the magnetic fields, and this all happens in a millisecond time scale.
What camera shutter speed are you using now, and how many frames per second?
4 million frames a second.
These astonishingly high speeds are necessary. Even at 4 million frames per second, this camera will only capture 14 frames of the flare. If everything goes as planned, the hydrogen gas will explode in the blink of an eye, creating a virtual solar flare that will live for just 1/300,000th of a second.
Let's go for it.
All right.
They gotta capture it on tape, like with the camera.
Maybe extending
many
beyond
pictures you take.
the original electrodes. We do see evidence of twisting here, and there are forces that are making this thing get bigger all the time. This sort of behavior was not predicted on the sun, but we clearly see that in our experiments.
Bellin and his team may be close to deciphering the power of solar flares here on Earth. But the true potential of our star can't be measured from 93 million miles away.